Imagine a world without computers, smartphones, or the internet. It's almost impossible to fathom, isn't it? Our daily lives are so intertwined with these technologies that we often take them for granted. This was our reality before the invention of the transistor. Back then, electronic devices were bulky, slow, and limited in functionality. Transistors are tiny electronic switches that control the flow of electricity. They can amplify signals and switch them on and off, making them incredibly versatile. They are the fundamental building blocks of modern electronics. Without them, the compact and powerful devices we use today would not be possible. These microscopic components have revolutionized our world. Transistors are everywhere, embedded in almost every electronic device we use. They are in our computers, phones, cars, and even refrigerators. Their presence is so ubiquitous that we often overlook their significance. Without transistors, our world would be a very different place. Imagine a life where communication is slow, and information is not readily accessible. In this exploration, we will delve into the fascinating world of transistors. We will uncover their history, understand their workings, and appreciate their impact. We will uncover their history, understand their workings, and see how they have evolved over time, and glimpse into their future impact. The potential of transistors is far from being fully realized. The journey of the transistor is a testament to human ingenuity. It showcases our ability to innovate and push the boundaries of what is possible. It is a story of scientific breakthroughs and technological advancements. Each discovery has paved the way for the next, leading to the sophisticated devices we have today. Join me as we embark on this captivating journey to unravel the mysteries of these tiny giants. Together, we will explore their past, present, and future. Prepare to be amazed by the power and potential that transistors hold. Their influence on our world is profound, and their future promises even more incredible advancements. The transistor's story begins in the mid-20th century. Scientists at Bell Laboratories were diligently searching for a solid-state alternative to bulky vacuum tubes. These tubes, while essential for early electronics, were inefficient, fragile, and consumed significant power. In 1947, the breakthrough came. John Bardeen, Walter Brattain, and William Shockley successfully demonstrated the first point-contact transistor. This invention marked a pivotal moment in history. The world had entered the age of solid-state electronics. This groundbreaking invention earned the trio the Nobel Prize in Physics in 1956. The impact of their discovery was profound. The transistor's small size, low power consumption, and reliability revolutionized electronics. It paved the way for miniaturization and the development of countless electronic devices. At their core, transistors are incredibly simple devices. Despite their simplicity, they are the building blocks of modern electronics, found in everything from smartphones to space shuttles. They consist of semiconductor materials, typically silicon. Silicon is chosen because of its excellent semiconducting properties, which make it ideal for controlling electrical currents. These materials have unique electrical properties that allow them to control the flow of electrons. This control is crucial for the functioning of various electronic devices. Imagine a water faucet. The faucet acts as a valve, controlling the flow of water. Similarly, a transistor acts as a valve for electrical current. A transistor operates similarly, controlling the flow of electrons instead of water. This analogy helps us understand how transistors manage electrical signals. By applying a small electrical signal to one part of the transistor, we can control a much larger current flowing through it. This small signal can be thought of as a key that unlocks a much larger flow of electricity. This ability to amplify signals is one of the key features of transistors. It allows weak signals to be boosted, making them stronger and more useful in various applications. It allows them to act as both switches and amplifiers. This dual functionality is what makes transistors so versatile and indispensable in modern electronics. When used as a switch, a transistor can turn a current on or off millions of times per second. This rapid switching capability is essential for the operation of digital circuits. As an amplifier, it can take a weak signal and make it stronger. This is crucial in applications like audio amplification, where a small input signal needs to be heard loudly and clearly. Let's visualize transistor operation using a simple analogy, a water valve. Imagine a pipe with flowing water. This pipe represents the flow of electricity. Now, picture a valve connected to this pipe. This valve represents the transistor. The valve has a handle that controls the water flow. A small amount of force applied to the handle can control a much larger flow of water through the pipe. Similarly, A transistor uses a small electrical signal applied to its base terminal to control a larger current flowing between its collector and emitter terminals. Just like the handle of the water valve, the base terminal acts as the control point for the transistor. Section 5. A family of switches. Exploring different transistor types. Over the decades, scientists and engineers have developed various types of transistors. Each type has unique characteristics and applications. Two main categories are bipolar junction transistors, or BJTs, and field effect transistors, or FETs. BJTs, like the common NPN and PNP transistors, use a small current at the base to control a larger current flowing between the collector and emitter. FETs, on the other hand, use an electric field to control the current flow. Within each category, there are numerous variations, each optimized for specific applications. Some transistors excel at high frequencies, while others handle high power levels. The diversity of transistor types enables their use in a wide range of electronic devices. Section 6. The heart of the digital age: transistors in modern electronics. Transistors are the unsung heroes of the digital age. They are the fundamental components that power our computers, smartphones, and countless other electronic devices. In computers, billions or even trillions of transistors are etched onto tiny silicon chips called integrated circuits, or ICs. These ICs form the brains of computers, performing calculations, storing data, and controlling peripherals. In smartphones, transistors are essential for communication, processing power, and display functions. Beyond computers and smartphones, transistors power our cars, control traffic lights, and enable medical imaging devices. The pervasiveness of transistors in our lives is a testament to their versatility and impact. Section 7. From supercomputers to smartphones, the pervasiveness of transistors. The influence of transistors extends far beyond our everyday gadgets. They are essential components in supercomputers used for scientific research, weather forecasting, and financial modeling. In the medical field, transistors enable pacemakers, hearing aids, and advanced imaging techniques. Our transportation systems rely heavily on transistors. They control engines, manage traffic flow, and enhance safety features in cars and airplanes. From the mundane to the extraordinary, transistors have become indispensable in virtually every aspect of modern life. The impact of transistors on society is immeasurable. They have revolutionized communication, entertainment, healthcare, and countless other industries. Our world would be a vastly different place without these tiny electronic switches. Section 8. The shrinking giants: Moore's Law and the future of transistors. Since their invention, transistors have been shrinking in size. Gordon Moore, co-founder of Intel, observed in 1965 that the number of transistors on an integrated circuit doubles approximately every 2 years. This observation, now known as Moore's Law, has held true for decades. This continuous miniaturization has led to exponential increases in computing power while driving down costs. However, as transistors approach atomic scales, physical limitations are becoming increasingly challenging to overcome. Scientists and engineers are actively researching new materials, designs, and manufacturing techniques to push the boundaries of transistor technology. Nanotechnology, quantum computing, and three-dimensional chip architectures are just a few areas of exploration. Section 9. A transistorized tomorrow: the enduring impact on technology. The future of transistors is filled with exciting possibilities. These tiny components, which have already revolutionized the world of electronics, are set to become even more integral to our daily lives. As these tiny switches continue to shrink and become even more powerful, they will continue to shape our world in profound ways. The miniaturization of transistors means that devices can become smaller, faster, and more efficient, leading to innovations we can only begin to imagine. The Internet of Things, or IoT, will connect billions of devices, all powered by transistors. This interconnected web of smart devices will transform how we live, work, and interact with our environment, making our lives more convenient and efficient. Artificial intelligence, or AI, will rely heavily on powerful transistors to process massive amounts of data and enable complex algorithms. These algorithms will drive advancements in machine learning, allowing AI to perform tasks that were once thought to be the exclusive domain of humans. From self-driving cars to personalized medicine, the future promises remarkable advancements driven by the enduring impact of transistors. These innovations will not only enhance our quality of life but also open up new possibilities in fields such as healthcare, transportation, and beyond. The journey of the transistor from its humble beginnings to its current ubiquity is a testament to human ingenuity. Over the decades, transistors have evolved from simple switches to the building blocks of modern technology, enabling the digital revolution. As we venture further into the 21st century, one thing remains certain: transistors will continue to be the heartbeat of our increasingly digital world. Their impact will be felt in every aspect of our lives, driving innovation and shaping the future in ways we have yet to fully comprehend.